What is happening in most of the distribution systems is these large diameter pipelines, when they go and when the withdrawal is too high and or there is a steep slope, pipe run partially full because of, and then there will be air entrapment because of sagging pipes and many issues will be there. So unless we address these issues, no amount of energy or pumping will help us. So this may be open channel flow, create air entrapment, and part of the system will be pressurized. So what manifold is, basically you convert this particular pipeline to three different pipes of 1/3 area. So this is, let's say, 900 mm pipe. This may be around 200 or 250 mm, three pipes you can use. And only for first 10 years you operate this. These two walls may not be operated for first 10 years. When demand increases, then you operate this. And then in the ultimate stage, you operate this. So this is the principle of using manifold. And you can have a lot of fine-tuned pressure gauges and air walls to take out the air. So a lot of such manifolds were used in 156 multi-village scheme in Amravati, but replications have not happened. So this particular model we are working for distribution systems now. So one such case we implemented in West Bengal. I'll explain the application. So application is in Dongaria region, in this region of West Bengal, because West Bengal Public Health Department called us for working with them to solve this issue. So they had this is in 24 South Pargana district. So they had a zone 9, and it is a multi-village scheme. And in one zone where 9 lakh liter capacity tank was there, 20 meter staging height, but water was not going ahead. So service reservoir was located somewhere here. First, what we did is we trained the entire PhD with this concept of shaft and manifold. I went with the idea of shaft, but then appropriately I found that manifold is more suitable there. We, as I told, partly hydraulic modeling, partly field work. You can see the entire chief engineer Animesh Bhattacharya sir and entire team. We work together on ground and monitor the entire system to study what is happening. First of all, even if there is a head, why we are not getting the water. So what we observed is, because the initial design, as per 3 peak factor, only one outlet was kept. The head loss in this particular premises, ESR premises itself, was 10 meters. So what I'm saying is, if this is the premise of the ESR and this is the tank, only in the premise, because of this huge head loss in the single outlet, then the branching will occur after the premise. But in the premise, tremendous amount of head loss we observed, 10 meters of head loss. So your tank basically operating at this level. The head is not utilized. We are basically wasting the head. So these simple findings you can have. So we monitored the entire system. You can see amount of pressure points we took. We monitored what is happening. Even using this hand pump, people were not getting water. They used to struggle a lot. So the reservoirs are here. Another issue was the planning. So the entire planning was not correct, because this entire region was planned on one single 9 lakh liter capacity. So you can imagine how far water can go. This is not magic, right? It cannot go like this. We have to plan for this. So decentralized infrastructure. Instead of 9 lakh liter, if they have constructed 3 tanks, 3 lakh liter capacity, this situation might have been avoided. So when we monitored, only this area was getting water. Rest of the people were managing somehow with other sources. So even if Ganga river was there, but they were not getting water, that's the irony of our situation. So this, what we first suggested is to convert single outlet to multiple outlet. So we asked them to install this manifold. We gave the design, and very promptly, very actively, they have installed this manifold. Then we asked them to do the zoning. And after this particular effort, water started coming in many areas. So again, the executive engineer and the team was there to see the commissioning and the results. So what we observed is, with the investment of let's say 25 lakh rupees for the manifold, earlier they were planning for a very big investment of for this particular area. But with this small investment, we could convert this low pressure to a high pressure system just by converting single outlet to multiple outlet. And when we monitored after the implementation, this much area was getting water. Still, there are areas. I told you, this is not magic that we can solve everything. We will have to do work step by step. Now there are outlets, remaining outlets we can use in this particular manifold. There are some spare outlets we have kept. Those can be used as express feeders to these areas, and then using shaft they can be distributed. So we have given this proposal also to them. So these spare outlets are there, and you can see the pressure before and outlet after. So and this is one feedback from the consumer.
क्या बोल रहे बोले पहले नहीं आया था, थोड़ा थोड़ा आता है, इसके बाद अभी पानी ज्यादा है। अभी हमने आज से ना आज से चालू है। कल नहीं था, परसों कल आला जब हमने चालू किया था। ओके।
So when we installed the manifold, the water, this lady got water after many years because there was no water reaching even with the hand pumps. So this we have also installed in Safale Palghar. This is in Malkoli, Bhivandi, where we converted this air wall to this manifold system, and 14 meter of pressure increase was there. So whatever work we did with West Bengal government was published in Minister of Jal Shakti Samwad journal as a success story. Minister of Jal Shakti has given directions to all the principal secretaries to use these innovations, try those innovations, and we will be happy to work. All the small cell tanks, multi outlets, manifold, shaft, they have given their so this is in public domain. This particular advisory they have issued. Non-mechanized water treatment plants, very useful for rural areas. Jal Tantra, pipe in pipe. Not all innovations have discussed, only few.